4.3 activity. How can we use multiplication and division to solve an inequality? We're going to work through this activity or lab. It says work with the partner. We're going to do it individually here. Where it talks about completing this table. Here's the inequality, and they gave us a bunch of numbers. So what we're going to do is we're going to plug in numbers, just like we did in lesson 1, and see, does -1 work in this inequality? So what you're going to do is you're going to take -1 and plug it in. So we're going to take 4 times this x value of a -1. 4 times a -1 gets us a -4, and that's where we now see. We plug this value in here and say yes or no. Is a -4 greater than 12? No, it is not. Well, let's check another value. Let's plug in 0 into this inequality. So we're going to take 4 times 0, which you can show your work up here for that, or you can write it in the box, which is what I'm going to do from now on. But now we check, is 0, does that work? Is 0 greater than 12? Nope. And so we just keep going. You're going to take 4 times the x value. Is 4, when we plug in 1, we get 4. Is 4 greater than 12? No. What's up next? Take 4 times this 2. That gets you 8. Is 8 greater than 12? No. We're taking 4 times our x value. So here it's 4 times 3. 4 times 3 is 12. Careful. Is 12 greater than 12? No. That's why we have an open circle, because it is exactly 12. So now when we plug in our next x value, 4 times our 4 up here, that gets us 16. So now we check, is 16 greater than 12? Yes. And what about the number 5? If I take that x of 5 and plug it on in, again, we're taking this value 5, plugging it in for the x. We have 4 times 5, gets us 20. Is 20 greater than 12? Yes. Instruction 1, complete the table. Instruction 2 decides which graph represents the solution. So we want the graph that's shaded just like this, where -1 is not a solution. It's not a solution. Not shaded, not shaded, not shaded, not shaded. Then we get to this 3, where there should be an open circle. And then we want the yes, because 4 works, so we want it shaded towards 4, and yes with 5. So that's this guy. And now again, write the solution to the inequality. So if they want you to write out an inequality from this graph or from the solution, that's where, again, you can start with that variable first, and then whatever numbers with the dot. And then we need one of our 4 inequality signs. Greater than, less than, greater than or equal to, less than or equal to. And as we're looking at those, again, since it's not greater than or equal to, since the dot is not circled, colored in, we don't want these. And now look at the shading. How do these numbers compare to 3? Is this direction greater than 3? Or less than 3. The numbers shaded are greater than, so that's why we want the answer x greater than 3. From there, part B. Again, checking some values to see if they work. We're going to substitute in these numbers into this spot. We're going to plug it in for x and fire away. So we're going to take that -3 times this x value of a -5. Careful, they're the same sign. That gets us a positive 15. So when I plug a -5 in here, I get 15. Is 15 less than or equal to 9? Nope. Do it again. We've got a -3 times our x value. Again, they've got that same sign, so that's going to get me that positive 12. Positive 12 less than or equal to 9? Nope. So what about when I take a -3 times this x value of a -3? That gets me 9. Now, is 9 less than or equal to 9? And we put down the word yes because it is equal to. From there, we just continue on. Take that negative 3 times this x value. You get 6. Is 6 less than 9? Yes. And we just complete the table. A negative 3 times a negative 1 gets us a positive 3. Yes, that's less than 9. 3 times this x value of 0 gets us 0. 0 less than 9? Yes. And then a negative 3 times this x value of a positive 1. They do not have the same sign, so we have a negative 3. And is negative 3 less than 9? Is negative 3 colder than a positive 9? Yes. So when you're looking at those, again, we've completed the table. Now which one of these graphs match? Where again, it's no, no, and then we start with yes. Our shading starts on negative 3 and continues yes to the right. So again, this first one, no, no, closed dot, and shaded to the right. Yep, it's this guy. So let's write out the solution to this inequality, where again I got x, or whatever variable you want, and then a negative 3 over here. And notice again, because it's a closed dot, I'm going to have a line underneath of it. And we're looking at how the shading goes. It's a little hard to tell, so it's going to the right. These numbers are greater than negative 3. So we want the greater than or equal to negative 3. Now that's interesting, because when we go back, we're going to talk about how to solve these inequalities. Just like solving equations, you find the variable, you focus on that 4 with that x. Since they're currently touching and timesing, to get rid of them, they're going to divide. And when you do that, the 4's cancel. You're left with x and 3. Now we've got this question that we're going to always ask right here. Did you and I multiply or divide by a negative? When you say no, nothing happens. So the sign stays the same, and that's exactly what we found out from our table. X is greater than 3. The numbers that work are greater than 3. That's what we have here with our shading. X greater than 3. Down here, again, solve this guy. Well, same thing. To get rid of that, we're going to divide by a negative 3 on both sides. That leaves me with x and a negative 3. And then we have this question, did you and I divide or multiply by a negative number? And when we say yes, that's when we flip our sign. Notice, because there was a negative coefficient, a negative number with our variable, that changed the values that work. We had to flip the sign, so let's take a look. It's x greater than or equal to negative 3, and notice that's exactly what happened. The values that work are greater than or equal to negative 3. That's what happened down here. So that's why we have this question. Did you and I multiply or divide by a negative? And we say yes, that's why we have to flip the sign, because that negative coefficient changes the values that work. On the back. Oh, it's a fraction. No, it's just division. So again, you're just going to plug it in. Whatever that x value is, plug it into here. So a negative 1 divided by 3. I'm just going to leave it as a fraction. Is a negative 1/3 less than 1? Is a negative 1/3 colder than 1? Yes. Plug in a 0. Plug a 0 in for this x value. So you have 0 divided by 3. That does just come out to be 0. And is 0 less than 1? Yes. We just keep on going. Plug a 1 in. 1 divided by 3, well, that's just 1/3. Is 1/3 smaller than 1? Yes. What about when you plug a 2 in for x? Is 2/3 smaller than 1? Yes. Plug a 3 in for that x value. 3 divided by 3, well, I'm going to simplify that. That's down to 1. Well, is 1 greater than 1? No. Plug a 4 in. That's an improper fraction, so if you wanted to say it's 1 1/3, you can do that, or just leave it as 4/3. 1 1/3 is not less than 1. And same thing. 5 divided by 3, well, that's more than 1. That's 1 2/3. So is 1 2/3 less than 1? No. Complete the table. Done. Which graph matches this? Where again our values are shaded to the left. It's yes to the left, which again, hard to see down here. The one shaded to the left is this guy over here, where -1 is an answer. 0 is an answer. It is yes. That's this guy. So write out the solution to the inequality. Notice again, x, that 3 from our answer goes right here, and they're shaded to the left. They're shaded less than. So we have the answer x is less than 3. A good practice here, because that comes up every once in a while, about just looking at your graph or your solution and writing an inequality from there. Ooh, lots of fractions. That's okay. We'll be all right. Plug it on in. A -5 for x over a -4. So now all I'm going to do is I'm just going to leave it, because they're common denominators, they got the same bottom number. Because they're both negative, that makes this a positive. Is 5/4 greater than 3/4? Since the bottom numbers are the same, is 5 greater than 3? Yes. Plug in that negative number on top. A -4 over 4. Well, that's just a +1 or a +4 over 4. Because they're fractions, I'm just going to leave it this way. A +4 over 4. Is 4/4 greater than 3/4? Since they have the same bottom number, is 4 greater than 4? Yes. What about a -3? Plug in a -3 over a -4. They have the same sign. So two negatives make a positive. So that means this is a +3/4. A +3/4 is greater than or equal to 3/4. Yes, because it is equal to, so that does work. A -2 over a -4. Well, that's a +2/4. Is 2/4 greater than 3/4? Is 2 greater than 3? No. Well, if I plug a -1 in, that's just 1/4. Is 1/4 greater than 3/4? No. Plug a 0 in. Well, is 0 or 0/4 greater than 3/4? No. And a +1 over a -4, well, that gets me a -1/4. Is a -1/4 greater than 3/4? No. So, once again, complete the table. Done. Find the one that matches the table to the graph. That's where we want it to be yeses up until that -3 and then switch to no's. So again, we want it to be yeses. We want it to be a yes and shaded for -5, -4, -3. So that's this guy. So once again, write out that solution. Start with the letter. Then put whatever number the dot is over here. Because it's a closed dot, it's going to have the line underneath of it. And then from there, because the numbers are shaded to the left, they are less than, they are colder than, so x is less than or equal to -3. When we go back through again, notice to solve these, all we're going to do is do the math. So here, well, looking at this one, how to get rid of that -4? Well, since it's being divided by, we're going to multiply both sides by a -4. -4 is a fractions and -4 over 1. These guys cancel. I'm left with an x. These guys, well, you could do the fraction dance to get a -12 over 4. Divide that on out, you get a -3. But now notice, we have one step of work. And we ask that one step of work, did you and I use work? Was our one step of work negative? When we say yes, we have to flip the sign, because when you have a negative number with that variable, when you do that operation, multiplying or dividing, that switches the numbers that work. Notice exactly what happens. We have to switch the sign because all the numbers that worked were less than or equal to -3, just like the graph. So that's why when we solve, again, x divided by 3, Multiply both sides by 3. And we have that one step of work where we say right here, we draw that arrow. Was that a negative number that you and I multiplied or divided by? No. Then nothing happens. X less than 3, that's what we found out as well. The numbers that work had to be less than 3. That's the same thing from our graph. So that's why when we multiply or divide by a positive, nothing happens. But when you multiply or divide by a negative, we have to switch the sign because the negative with the variable changes. It flips the numbers that work. The 4-3 puzzle worksheet. If you've been in class and you've watched the video before, might have talked about how the textbook always puts the letter first. So you can see how today, when we're checking our answers, the variable's always going to go first. So you and I can write the answer two different ways. So that's where, join me on number 4. That's supposed to be a negative 15 greater than or equal to x over 3. Solve. Well, to solve, you and I are going to focus on this side. How do you get rid of dividing by a positive 3? We're going to multiply by a positive 3. Yeah, you take the 3 times a negative 15, get you a negative 45. Leave a space there, and then these 3's cancel, so you're left with x. But now you and I have a question that we have to ask every time we multiply or divide. So yes, draw that arrow to one of these 3's that you multiplied. Did we multiply by a negative? Nope. All right. So then nothing changes. This is the answer. And this is the answer that I would have. This is the answer I would accept. Now again, we've taken time in class to talk about it. The textbook will reverse everything, so the letters first. So if you're going to reverse everything, if you're going to reverse and put the x first, and then put the negative 45 over here, you have to do the same thing with your sign. It's like the whole thing is just being flipped or reversed over, rather. So you got to reverse the sign. So both of these are correct answers. But when you start looking for these, you say, Mr. Wallace, there's nothing that starts with a negative 45. All right? So then you can reverse everything so that your letter, your variable, is first. So this is the answer that you'll be looking for today, even though this one also works. So you can see number 4 is the letter T. So number 4, the letter T. So same thing. You can solve them. 1, 2, solve it. The variables first. You'll find your answer. No problem. Number 6. Here we go. Zooming on into number 6. That's a negative 1.5x. So that's supposed to be touching and timesing. So to get rid of that, I'm going to divide by a negative 1.5. Now, we did that because these guys cancel. You're left with x on the right side. These are not the same sign, so you're going to get a negative 6. But then, yes, you have to. You have to stop and not just only mentally ask yourself or quietly ask yourself, did we multiply or divide by a negative? You need to write it on out. You need to ask yourself, did we do one step of work? Did you and I multiply or divide by a negative? Since we say yes, put down a big capital flip. You and I need to flip the sign to have the correct answer. That's the correct answer. But now when you go looking, you say, Mr. Walls, there is no negative 6 first. All the letters are first. All right? So then, as we've talked about before, this answer works. This is good. This is good. This is the correct answer. But if you need to reverse, go ahead and make that note to yourself. If you're going to reverse everything to get that letter first, make sure you reverse that sign as well. So when you're reversing the location of the negative 6 and the x. This is the answer that we're looking for today because of the book's assignment. So from there, again, this is a good answer. You can leave that. But to find the answer we're checking on today, the textbook has everything first. So notice again, this it says negative 6 is greater than or equal to x, all the other numbers. We can say that same answer as x is less than negative 6. This is what we're looking for here. Be very careful. There's a lot of 6's on this one. We want x less than or equal to, negative 6. So number 6, letter U. Remember, rule number 1, shh, don't shout it out. Once you know the answer to the puzzle or the joke, don't shout it out. Rule number 2, you still need to show the work so that way your work matches the answer that's supposed to be there, so that way you know you're doing it right.